So
I'm not even done yet.
yesterday we talked about how to multiply a monomial times a polynomial, and today we're going to work on doing a polynomial times a polynomial. There's a couple of different ways to do this. Yes, ma'am?
Are there polynomials as like graphs?
Yes, you can graph polynomials. In fact, we're going to, probably not this week, but next week. We're gonna graph some real basic ones called quadratics, which is just x squared. But as you go a little farther in math, you'll graph x to the third, x to the fourth,
So like,
etc.
If we go a little bit farther in math, will that be this year or next year or the year?
Not this year. This year we stop at quadratics, which is x squared. They look kind of cool. They look like a horseshoe. That's what the graph of y equals x squared looks like. You don't need that in your notes, but... Huh? That's what it looks like. You don't really need that in your notes yet, but that's where we're going with this. But right now we're just going to multiply them. And there's a couple of different ways to multiply, and I'm going to show you a handful. The one that I learned whenever I was in school, way back when the world was in black and white, was a method called FOIL. Have you ever heard of this?
No.
I don't love this method of multiplication. Oh, that's very funny. The cooking product, yes, hilarious. I don't love FOIL, but some people find it to be really helpful for remembering which order to multiply things in. It stands for first. The O is either outer or outside. And then the I is either inner or inside. And L is last. It's the order in which you multiply a binomial times a binomial. The reason I don't particularly like it is because it only works for a binomial times a binomial, which we do a lot of, but it doesn't work for a binomial times a trinomial, for example. So I'm going to show you FOIL just because that's how I learned it, and that's how a lot of math teachers still teach it, but I don't love FOIL. So first means the first terms in each set of parentheses. So the first term in the first set is the 2x, and the first term in the second set is x. So the first thing I would do is 2x multiplied by x, which is 2x squared. The next thing that I would multiply are this is O, outer, the outside terms. So of the whole problem, the terms on the outside is the 2x and the plus 5. So that's what I would multiply next. 2x times plus 5 is 10x. The I stands for inner. The innermost terms are the 3 and the x. So 3 multiplied by x gives me 3x. And then finally, the L stands for last. The last term in the first set of parentheses is 3. The last term in the second set is 5, and 3 times 5 is 15. So FOIL is the distributive property. First, we distribute the 2x to the x and the 5, and then we distribute the 3 to the x and the 5. It's distributive property. FOIL is just a way to help you remember an order that will make sure you multiply everything. It'll make sure you don't forget to multiply any two things together, because you can see just from my arrows, this can get a little complicated. Do we have anything in this new problem that can be combined? Very good. 10x and 3x is 13x. So my final answer is 2x squared plus 13x plus 15. There's nothing wrong with the FOIL method. It's just not my favorite because it only works for a binomial multiplied by a binomial. It's not like my favorite thing in the whole world. I'll show you in a little bit. First, I'm going to show you my second favorite way to do this. We're going to do the exact same problem, except I'm not going to write it in highlighter. The exact same problem. I want to show you how to do this with the box that we made yesterday. So this is a binomial multiplied by a binomial, so I need to make a box that is a 2 by 2. I really like the box method if you're having trouble staying organized. This is a really good way to stay organized, and also it uses way less lines than the FOIL method. See, I did a lot of marking on that problem for the FOIL method. Less marking for this one. So it's 2x plus 3 times x plus 5. So I'm going to put the 2x plus 3 along one side, and I'm going to put the x plus 5 along the other side. Doesn't matter which side is which. And just like yesterday, we're going to solve this just like they are Punnett squares. So I'm going to do 2x times x would be, that you're thinking plus. 2x times x is 2x squared, and I'm going to put that in the intersection box of 2x and x. So 2x multiplied by x gives me 2x squared. Okay. Then I'm going to do 2x times 5, which is 10x, and I'm going to put that result in the intersection of 2x and 5. So I like that. And then we'll fill in the second column. So I'm going to do, the first one is 3 times x.
3x.
And then finally, I'm going to do 3 times 5, which is 15. Now you'll notice that what I wrote here in these boxes is the exact same thing that I wrote when I did FOIL. I got the 2x, the 2x, oops, wrong spot. 2x, 10x, 3x, and 15. I got the exact same thing. The box just kept it a little more organized. My answer is still 2x squared plus 10x plus 3x plus 15, and then I combine the 3x and the 10x.
Does it have to be in order?
Be more specific. What do you mean by order?
Does it have to go like 2x to the second or something like that?
You should get into the habit of writing your final answer going from highest exponent to lowest, just like this. It would not technically be wrong. I'm using the world's largest air quotes here. It's not technically wrong if you did something like this. That is a correct answer, but it's just not good practice to write it like that. Where you go from the biggest exponent to the smallest, it'll make things a little easier for you down the line.
So if the number has an x, that's automatically bigger than just 15.
Right, because 15 doesn't have a variable at all. So if I'm writing it from biggest exponent to smallest, 15 would have a variable exponent of 0. 15x to the 0 power is 15. I prefer that when you do these, you just think of them as being the distributive property. And if you just think of them as distributive property, you won't have to worry about, is it a binomial, is it a trinomial, is it a monomial? Just do distributive property every single time. I'm going to take this x right here, and I'm going to multiply it by the 3x and the 4. And then I'm going to take this minus 2 right here and multiply it by the 3x and the 4. Just think of it like distributive property. That works for every one of these problems. FOIL, as you'll see in a little bit, I'm going to give you some FOIL examples that don't work very well using FOIL. All right, so let's go ahead and distribute the x first. So I'm going to do x times 3x, which is good. And then I'm going to do x multiplied by 4, which is 4x. Great. So now I have distributed that x to both things in the second set of parentheses. The x has been multiplied by both the 3x and the 4. Now I'm going to do the same thing with the minus 2. The minus 2 gets multiplied by 3x, minus 6x. And then the negative 2 gets multiplied by the 4, and negative 8. Very good. And then the last question I ask myself is there anything that can be combined? Good. The 4x and the minus 6x can be combined to give me, there we go. Which means my final answer is beautiful. I think this is a much better way to solve the problem. Just think of it as distributive property so that whenever we start doing like trinomial times trinomial, you don't try to do FOIL with it because FOIL won't work. FOIL only works binomial times binomial. FOIL is really useful as a shorthand way of saying multiply these. You just say, oh, just FOIL it. You'll hear people say that a lot. When they say FOIL it, they mean multiply it using the distributive property. So hopefully you don't find this to be too much more difficult than what we did yesterday. Yesterday we distributed one thing. Today we are distributing two things, but it's still just distributive property and then combine your like terms. I'll give you two of these to practice on your own, and then we'll do a little more challenging problems. So take a few minutes and try those on your own. Okay, so let's talk about the answers to these problems. So on the first one, I'm going to distribute the 3m. So I do 3m times m. And then I do 3m times 5.
Which would be 15m.
Good. And then I will distribute the positive 4. So 4 times m.
4m.
Good.
And then 4 times 5 is 20.
There we go. Is there anything in that problem that I can combine?
Yes, the 15m
Yes.
plus 4m, which would be 19m, which would be 3m squared plus 19m plus 20.
Oh, she's on a roll. Well done. Great job. Sure, you can do the next one. So I'm going to distribute the 5y.
To the other y, and you would give 5y to the second power.
Good.
And then you would distribute the negative 2 to the y.
Whoa, hold on.
What?
A minute. You only distributed the 5y once.
Plus 40y.
There we go. Great.
Then you distribute the negative 2 to the y, positive 8.
Good.
To get negative 2y minus 16.
Good.
And you can combine the 40y and the minus negative 2y to get 5y to the second power plus 38y minus 16.
Perfect. There's our answer. Well done. Saw some really good answers on that one. Really good answers. Oddly enough, the most common mistake that I saw was on the first one. I had about 3 people tell me 4 times 5 was 20m. Put an m in there. That was a common mistake, believe it or not. Okay, now I promised to give you a problem that can't be done using FOIL, and here it is. This is why I don't like FOIL, because of problems like this. I like FOIL if I'm having to cook meat on an open fire, or if I'm having to protect my brain from alien invasion. But otherwise, I'm not a big fan of FOIL, because when you get a problem like this is a binomial multiplied by a trinomial, and FOIL doesn't work. If I try to do FOIL here, I'm going to completely miss multiplying by the minus 3x. Yes, ma'am? Because if I do first, the first terms would be these two. Outer would be these two. Sorry, not those two.
Inner. Wait, what about inner?
Outer would be these two. Inner would be these two. And last would be these two, which means I completely missed our poor friend minus 3x. He's all alone. So this is why I suggest you think of this like the distributive property. Now, when you get a problem that's really complicated like this, where there's a bunch of stuff being multiplied, the box method is really, really good. Since this is a binomial multiplied by a trinomial, I need to make a box that is a 2 by 3 or a 3 by 2. How did I figure what out? Because the first term only has first polynomial only has 2 terms in it, the 6x and the plus 5, and the second polynomial has 3 terms in it, 2x squared minus 3x minus 5. So I just needed to make one big enough where I could fit one polynomial along the left side and another polynomial across the top. The distributive property absolutely works here, and if you're really good at these, distributive property is faster. And if you're not really good at these and you find yourself getting disorganized and messed up a lot, use the box. So let's start off with the 2x squared and we'll go straight down. So 2x squared times 6x is 12. How about x to the third? X times x squared is x to the third. And then 2x squared times 5 is 10x squared. Okay, now I'm going to do the minus 3x, and I'm going to multiply my way down. So minus 3x times 6x is?
Negative 9x.
You're adding. Multiply. 3 times 6 is 18. Not x. X is the second power. Very good, Christian. And then negative 3x times 5.
Negative 15x.
There we go. And then the last one is the minus 5,
Negative
multiplying down.
30x.
Negative 30x, good.
And then 25.
Oh,
Negative 25.
there we go. Negative 25. So the answer to this problem is 12x cubed plus 10x squared minus 18x squared minus 15x minus 30x minus 25. There are 6 things in the answer because there were 6 boxes after I got done multiplying. So there are 6 terms. But that's not how I'm going to write the answer because I see some things that I can combine, like, how about this? What does that give me a total of?
8x to the
Oh,
negative
negative 8x.
to the 4th power.
Oh,
1.
when you subtract or add, the exponent does not change. So it's still x squared. Anything else I can combine?
The negative 15x and the negative 30x give
Negative 45x, thank you. So 12x cubed minus 8x squared minus 45x minus 25. That doesn't seem too bad. As a matter of fact, I'll bet that's the worst they ever get.
No.
No. Mr. Taylor.
What? False hope. We don't know you anymore, Mr. Taylor. I mean person.
Oh, wait. So you just did the 2y squared times the 3y squared, and then you did 2y squared times the 5y.
Ah, so Maddie is being a math pro and saying, I'm going to just do distributive property. So what she just said was, why don't you just do 2y squared times all 3 of these, and then do 3y times all 3 of these, and then do negative 1. Oops. Negative 1 times all 3 of these. It looks like it's more work, but it's not. It's the exact same amount of work. It's actually a tiny little bit less work because you don't have to draw the box. Tiny little bit less work, but also it's a tiny little bit more complicated. If you don't draw the box, it's a lot easier to skip something by mistake. It's a lot easier to forget to distribute something. So I would say distributive property is great once you get the hang of it. Before you get the hang of it, maybe use the box method. How big is my box going to have to be?
9 numbers.
9 boxes, so it's a 3 by 3. Because this is a trinomial multiplied by a trinomial. So I'm going to use the box to try to get the right answer.
Oh my god.
Right, kids?
Oh my god,
Right?
Mr. Taylor, no.
Good job. Good job.
I should go to the joke corner. The bad joke corner? I think you mean the awesome joke corner because that joke was amazing.
Good job. Good job.
Thank you, Zeke. Thank you. Finally, the respect I deserve. All right, walk me through this one.
The 3y squared times 2y squared would be 6y to the fourth power.
Good. So Maddie wants to multiply the 3y squared first, going straight down. 3y squared times 2y squared, she said, was 6y to the fourth. Well done.
And then it would be 9y third to the third power.
Good.
Mr. Taylor, you're going to do that.
And then it'd be negative 3 to the negative 3y to the second power.
What'd you say, Peyton?
So you're going too fast.
I'm going at Maddie's speed. It's her problem. Maddie, you're leaving everybody in the dust. Slow down, woman. It's not a competition.
I'm
At
not
least-
saying it is.
At least not much of one. Because if it was, Maddie would be killing it.
And then negative 5y times.
Calm down. Calm down. Not everybody is a math expert. I mean, everybody in this class is because they have such a good-looking math teacher, but
No.
That's right.
Should've said yes.
okay,
Now,
next.
Negative 5y times 2y would be negative 10y to the third power.
Good.
You're going too fast.
And then
And then it would be negative 15 to the y.
To the second power.
y squared.
And it'll be negative 5y.
Squared.
Positive.
Positive 5y.
Thank you. Very good, Andrew. Positive 5y. Negative 5y times negative 1 is positive 5y. Well
and then
done.
it would be 2 times 2, which is 4, so it would be 2y squared.
2 times 2 is 4, so it would be 2y squared.
4y squared.
4y squared.
And then it'd be 6y
Yep.
squared.
Oh, why do you hurt me?
Third to the third power.
That's even worse. You're breaking my heart. Do you hear that sound?
Cubed.
Do you hear that sound? That's the sound of my heart breaking.
6y.
I don't hear anything.
To the first power, just 6y.
And then it would be negative 2.
Negative
Be
2.
Negative 2.
I wasn't.
So my answer is 6y to the fourth plus 9y cubed minus 3y squared minus 10y cubed minus 15y squared plus 5y plus 4y squared
You're going too
plus
fast.
6y minus 2. I'm just rewriting what's already on there.
Yeah.
I think I got the answer.
So there should be 9 total terms in this answer because there were 9 boxes. The question is there anything I can combine? With a problem this big,
Yeah.
a good way to keep organized is to start with the biggest exponent and work your way down. So the biggest exponent is y to the fourth. Is there anything else in this problem that is y to the fourth?
No.
No. So I'm going to just do 6y to the fourth. Okay? Now let's go y to the third, the next highest exponent to the third, 9y to the third. Is there anything else in this problem that's y to the third?
Yes, negative
Yes.
Y to the third.
Negative 10y to the third.
10.
When I combine those, what do I get?
You would subtract, right?
Mm-hmm.
Negative y to the third.
Good. Negative 1y cubed. Perfect. Then, let's go y squared. I have negative 3y squared.
There's 2 of them. There's negative 15y squared
Mhm.
and positive 4y squared.
Mm-hmm.
And you'd subtract all those, which would be no idea.
Being no
I'm sorry, no idea is not the correct answer, although it is a common
Negative.
guess.
1.
I like the 6y.
Hold on, we're still combining the y squareds.
Oh, I'm right.
What'd you get for when you combine the y squareds?
The y squared.
Negative 22.
24y.
It's negative 22. I got negative 22. Negative 15 minus 4 minus 3.
No, it's not minus 4, it's plus 4.
Wait,
Would be 11 minus
It's negative 18 plus 4.
Negative 14.
Negative 14.
Oh. But hold on, Mr. Gill.
Yes?
If you do a negative plus a negative 15 and 3 are yes.
And then you'd add those,
Wouldn't
which
you
would
get
be
negative
11.
And negative 18 plus 4 is negative 14. And then minus 2 doesn't have any buddies, so just minus 2.
Okay, so now we're done.
That's the answer.
Okay, that was tiring but fun.
That wasn't
No,
fun.
it wasn't
Daddy,
fun
I-
at all.
It was
What are you
fun.
talking about? These
Mr.
are
Taylor.
Okay,
look back.
other than giving me your opinions on whether this is fun or amazing or tiring or you wish you were dead, does anybody have any questions? Yes.
I have a question.
Does the order you put them in matter?
The order you put the final answer in matters. Up until then, no, it does not matter.
Okay.
Yes, sir.
When you're gonna teach you how to factor that back.
Couple weeks.
Okay.
When are we ever going to use this in real life?
I don't know what your real life is going to be, Zeke.
I was trying
But I have to use
explain
this
that
as a
to you.
nurse.
can't
I don't know what you're
explain
going to do in
it.
real life, so I can't answer that
When are we
question.
ever going to use this stuff? Like,
I don't know when you're going to use it because I don't know what you're going to be when you grow up.
I'm going to be a nurse, pediatric nurse. Would I have to
Maybe.
use that? Probably too late for those who do medicine and stuff, right?
Beats me. I'm not a pediatric nurse. I don't know.
I'll just have to ask March 3rd when I go to one. And if Dr.
When you just start doing things, I'm like, okay.
You're going to use this in real life whenever I give you a quiz over it. That'd probably be the next time. That might not be the only time, or it might be the only time.
What careers do you need this for? Math?
This actually comes up quite a bit in calculus. You have to be really good with polynomials to do calculus.
Never doing
And calculus,
Calculus
for
is
better or
disgusting.
worse, makes the world go round. You think calculus is disgusting and you've never done a single calculus problem. That is a bold statement.
So it makes rockets fly.
It is what makes rockets fly. Makes your cell phone work. I know
Come on,
you kids
brother
don't care
babe.
about cell phones.
I could live without one.
same.
Like, if I have to learn calculus, I'd rather just have no cell phone. Rockets, who needs them? I'll just live on Earth forever.
Until we.
Yeah, polynomials are big time calculus stuff. So when/if you take pre-cal and calculus, they come up a lot.
After algebra 2, I'm going into that actually.
Yeah, maybe.
Yeah.
Okay, are there any other questions besides, please God, I don't want to? You use it in calculus-based statistics, but in intro to statistics, which is what you take in high school, no, we do not use polynomials. Okay, I take it there are no questions about what we actually learned today? Just questions about what you want to be when you grow up? Yes? Yes. Yes?
I don't know what I